of inequalities by graphing. Okay, so we're going to graph each of these. We're going to shade a certain direction after we plug in a point. And then see where our solutions are. So systems of quadratic inequalities can be solved by graphing. So we do have our first example here, solving this system by graphing. We have to first identify what type of equations we have. Okay, so I have y is greater than x squared plus 1. So if one of those variables has a squared value, okay, that is a parabola. Okay, so I have a parabola. The second one, both of those values are squared, and I have a value off to the right. What type of equation do you think that is? It's a circle. Okay, so that second one is a circle. Okay, so step one, we're going to graph the equations. Okay, for the parabola, we can make an XY chart. Okay, the vertex of this parabola is at 0, 1. Okay, your h value is 0 because that's next to x squared. Your k value is on the outside, that's 1. Okay, so our vertex is at 0, 1, and we can plug in points between those two. Okay, so I can plug in -1, +1, +2, so on. So if I plug in -1 for x squared, -1 squared is 1, 1 plus 1 is 2. Okay, again, plug in 1. Okay, 1 squared is 1, plus 1 is 2. Plug in 2. 2 squared is 4, 4 plus 1 is 5. Now, when you graph this, you do want to be careful with your inequality. Okay, since this is just greater than, this is a dashed line. Okay, that is a dashed line. When you see it as less than or equal to or greater than or equal to, that's a solid line. Okay, so our parabola with these points will have a dashed line. So I'll plot those points. So I have -1, +2. I have 0, 1, 1, 2, and 2, 5. Okay, if I were to plug in -2, I would also get 5. Okay, so I would just connect all of those with that dashed line. Okay, next I want to graph the circle. Okay, your circle's center is what? 0, 0. Okay, so this is for the circle. Center is at 0, 0. Okay, radius. Okay, your radius is equal to the square root of that last number. Okay, square root of 9 is 3. Okay, so I have my center point at 0, 0. From that center point, you can count up 3, right 3, down 3, and left 3 to plot the points for that circle. Okay, and again, this one is a solid line because it was less than or equal to. So we just have to connect the dots there. Ooh, that was bad. Okay, next, since these are inequalities, we have to figure out where we're going to shade. Okay, so step 2. We're going to pick a point. Okay, so I want to pick a point that is not on the graph. Okay, so not along the line of that parabola. Okay, so when you can, pick 0, 0. Okay, your parabola's vertex is above that, so we can pick 0, 0 for this. Okay, so I'm going to pick 0, 0. That is at x and y. I'm just going to plug in 0 for both x and y into that equation. So we have 0 is greater than 0 squared plus 1. And we want to see if this is true. Okay, so I would have 0 is greater than 1. Is that statement true? No. Okay, so that means where I'm going to shade, since 0, 0 is on the outside of that parabola and that wasn't true, your shading is on the inside. And don't shade it a lot. Okay, we want to see where these shaded sections intersect. Okay, next I want to do the same thing with the circle. Okay, your circle goes around 0, 0, so you can plug in 0, 0 as a point again. And we will just plug those in for x and y in that second equation now. Okay, so 0 squared plus 0 squared is less than or equal to 9. So we have 0 is less than or equal to 9. Is that statement true? Yes. Okay, that means we're going to shade where 0, 0 is in that circle. So that would be on the inside. So we're trying to find where these two shaded sections intersect. Okay, they're both shaded in this small area right here. So that's where I would do that darker shading. And that would be your solution. Okay, do you see that? Okay, questions on that first one? Again, we can use Desmos to check. So I'm going to show you really quick. So you see how we shaded inside this parabola and it is a dashed line. Okay, it was inside of it. Same thing with the circle, solid line, shaded inside. And then they overlap right here in this section. And that's where your darker shading should be. All right, we're going to do the second one. Okay, getting a little bit more challenging here. So, again, solving the system of inequalities by graphing. The first one, we have x squared minus y squared less than or equal to 8. Now, it's not a circle. A circle has to be plus between them. Okay, so if you have a subtraction symbol between those, do you remember which one of our conic sections that is? If there's subtraction between your two squared values. Not an ellipse. What's the other one? Hyperbola. Okay, so if you have that subtraction between, it is a hyperbola. So I'm going to rewrite what that would look like because hyperbolas are always equal to 1. In this case, your inequality will be less than or equal to 1. So that means you have to divide by 8. Okay, so for this hyperbola, we would have x squared over 8 minus y squared over 8. Oops, not equal to, less than or equal to 1. Okay, and in this case, for your hyperbola, your a and b values are then just going to be the same. Okay, because a is here, b is here. Again, you just take the square root of those to get your a and b value. Okay, so your center for your hyperbola, you should know this one. What's the center for the hyperbola? 0, 0. Okay, center is at 0, 0. Your A value is the square root of that first one. Okay, that's about 2.8. Same thing with your B value. It's the square root of that second one. It's about 2.8. Okay, so this is a horizontal ellipse since your A value is underneath x squared. It is horizontal. So to graph our hyperbola, we need the center, we need the vertices, and then we need the asymptote. Okay, so your vertices, we need to change our h value. Okay, so it's going to be h plus or minus a. Okay, so since h is 0, we're just adding on 2.8. And we're keeping k the same. And this one will just subtract 2.8 from 0, so negative 2.8. Okay, I don't need the covertices to graph it. So the last thing I need to graph a hyperbola is the asymptotes. Okay, the asymptote for a horizontal hyperbola is plus or minus b over a. Okay, so our a and b value are both 2.8. So we have plus or minus 2.8 over 2.8. And if I have a number over itself, that's just 1. Okay, so it is just plus or minus 1 for that slope. Okay, so we are going to graph this hyperbola. Again, looking back at your inequality, it is less than or equal to, so it is a solid line. So I want to plot the center point at 0, 0. Use our asymptote slope, okay, to find that asymptote. It is just up 1, right 1, up 1, left 1. Okay, remember it has to make that x. So asymptote's just going to go through with a slope of 1 each time on both sides. Okay, so those are your asymptotes. Then you can plot your vertices. So we have a vertice at 2.80 and negative 2.80. And again, we can then just create those curved lines where they approach the asymptote but never cross. Okay, so that's that hyperbola. Okay, next we have our second equation here. What does that equation look like? X squared plus y squared greater than or equal to 120. You have to identify what type of conic it is before you can graph it. This is a circle. Okay, so to graph your circle then, we need our center. Okay, center is at 0, 0. Your radius is the square root of that last number. Okay, the square root is like 10.9. We're about that. It's almost to 121, so it's almost 11, but it's not. Looking over here, it is greater than or equal to, so it is a solid line. Guess it will go off of your graph because your graph only goes to 10. So your center is at 0, 0. You have to go up to 10 and a little bit more, over to 10, a little bit more, all 4 directions. Again, I know it's off your graph. Okay, then connect those. That was a bad circle. Okay, what do I have to do next? What did I do in the top? What is step 2? What's step 2 at the top? Pick a point. Okay, so I need to pick a point for both of these graphs. Okay, again, I can pick 0, 0 because those lines don't lie or don't cross that center point. And again, 0, 0 is always the easiest point to check. Okay, so for the hyperbola, okay, we're going to use 0, 0. Plug in 0 for x and 0 for y. Okay, so if I have 0 over a number and 0 over a number, it's still just 0. So 0 is less than or equal to 1. Is that true? Yes. Okay, so that is true. That means for the hyperbola, we're going to shade everything in between those two lines. Okay, so very lightly, we'll shade everything in between those two lines that go out to the sides. Okay, we want to check a point for the circle as well. And again, I'm going to just check 0, 0. And you plug that in for x and y into your equation. So we have 0 squared plus 0 squared is greater than or equal to 120. So 0 greater than or equal to 120. That statement is not true. Okay, so that means I'm not shading on the inside of the circle. I would be shading on the outside of the circle. Okay, so around the outside part here. So we want to see where those two shaded regions intersect. Well, I see I have a shaded region here and here for both, and down here for both. Okay, so our shaded combined region would be above here and below here. Okay. So again, I can show you that on Desmos. Again, Desmos is a great tool for you to check if you're doing it correctly. Okay, so here's your circle and your hyperbola. Hyperbola is shaded on the inside, circle shaded on the outside. We shaded on the inside of that hyperbola. So your darker region right here and down here should be shaded on your paper. Okay. Questions on this one? So you still need to look back at those graphing properties for each of your conic sections. All right, we're going to do one more. Okay, one more. Again, we're going to identify what both of these equations are. What's that first one? It's the top equation. What type of conic section? I only have one squared value. That's a parabola. This one, I have squared values over a number and there's addition between, and it's less than or equal to 1. That is your ellipse. Okay, less than or equal to 1, addition between those two fractions. Okay, so I need to graph both of these. For the parabola, I do have a dashed line. And for the ellipse, I have a solid line. Okay, so first our parabola, graphing that. Our vertex point is at HK. So H is on the outside of this one, K is on the inside, because this is a parabola that goes to the right, because it's an x greater than 1. Okay, so H is on the outside, K is on the inside. So our vertex is at 2, -3. Okay, so from here I can make that XY chart. And remember, you want to plug in values for y for this one, not x. So I want to surround y in order to solve for x. So I can plug in -4, I can plug in -2, and -1. Okay, so if I plug in -4 for y, I get -1. -1 squared is 1, plus 2 is 3. If I plug in -2, I end up with 1 inside parentheses there. 1 squared is 1, plus 2 again is 3. Plug in -1, I get 2. 2 squared is 4. 4 plus 2 is 6. Okay, and then I can just plot those points. So I have 3, -4, 2, -3, 3, -2, and 6, -1. Okay, and remember this one is dashed. Okay, so I would make that parabola dashed. Okay, next I want to graph this ellipse. The center of this ellipse is at 0, 0. Okay, your A value is your greatest term. So to find A, we'll take the square root of the greater number in the bottom. That's 6. And B is the square root of the smaller number. That's 4. Okay, that'll help us find our vertices and covertices. Since A squared is underneath Y, this is a vertical ellipse because Y's run vertically. Okay, greater number is underneath Y and Y's run vertically. Okay, so that means I need to change the K value for the vertices. Okay, so H stays the same. I need to add the A value to K. So add 6 to 0 is 6. And subtract 6 from 0 is negative 6. And then I need the covertices. We're going to change the h value this time with b. Okay, so add 4 to 0 and keep k the same. And subtract 4 from 0 and keep k the same. Okay, so we can plot these points. Our center is at 0, 0. Our vertices are at 0, 6 and negative 6. Covertices at 4, negative 4. This is a solid line. We can just connect those points. Okay, next I need to test out my points. Again, I can just pick 0, 0 for both. Okay, so if I plug in 0, 0 into my first equation, we have 0 is greater than 0 plus 3 squared plus 2. Okay, so 0 is greater than 9 plus 2, which is 11. Okay, that is not true. No. So since 0, 0 was on the outside of that parabola, I'm going to shade on the inside of the parabola. Again, just lightly. We want to do the same thing for the ellipse. So again, plug in 0, 0. So we have 0 squared over 16 plus 0 squared over 36 is less than or equal to 1. Okay, I end up with 0 is less than or equal to 1 there again. That is true. So that means I'm shading inside the ellipse on that graph. And we want to see where they cross. It's that very small section between the two. Okay, that very small section between the two. Okay, questions? Oops. Okay, again, I'm going to show you on Desmos really quick. Yeah? Okay, so we shaded inside the parabola and we shaded inside the ellipse. Okay, that small section right there is where they overlap. Okay, so that's what you have to look for in your shading. And again, please use Desmos to check your answers. Okay, so just graphing each of those conic sections. Do you have any questions on that?